So now we're gonna ask a couple of our friends how much they know about our topic. Excuse me, sir, can you tell me what an empirical formula is?
No idea.
Sir, let me enlighten you.
So the empirical formula is the simplest formula for a compound. A molecular formula, on the other hand, is the same as or a multiple of the empirical formula, and it is based on the actual number of atoms in each type of the compound. So for example, if the empirical formula of a compound is C3H8, its molecular formula may be C3H8 or C6H16.
Now we're going to talk about the 3 easy steps to determine the empirical formula. First step, assume a 100 gram sample. Second, use the molar mass to determine the moles present in the problem. Third, calculate the mole ratio. We'll talk about that later. Here's an example. A compound was found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. What is the empirical formula? So first, we list the given amounts of elements in the problem. Then, using the molar mass, we find the moles present in the problem. Using the smallest amount of moles present out of all of them, you divide to find the mole ratio. This will give you the simplest ratio of elements present in the formula. So put these numbers together and this will be your final answer.
Excuse me, can I ask you a question? Yes. Do you know what the molecular formula is for any given compound?
No.
Okay. A molecular formula gives the number of atoms of each of the elements present in one molecule of a specific compound. However, it does not show their structural arrangement, so that is what the empirical formula is for.
So if you can find the empirical formula and know the molar mass, you can find the molecular formula. So for example, many compounds have the empirical formula CH2O. The molecular weight of a specific compound is 180 grams. So what's the molecular formula? So you'll take the molecular mass, 180 grams, which is given to you, and divide it by the molar mass, which will give you 6, which is the multiple that you'll apply to the empirical formula. So then you'll take your 6, so the resulting empirical formula will be C6H12O6.
Excuse me, miss? Can I ask you a question?
Yeah?
Do you know how to balance a chemical equation?
No. So in order to balance an equation, you have to have the same number of each element on both sides. In this case, the answer would be 1, 4, 1, 5. Now that you have a balanced equation, it's time to check it. In order to check your equation, you have to count the number of atoms on each side to make sure they're the same. For example, there's 1 phosphorus atom on this side, so 1P. And then there's 1 phosphorus atom on the right side, 1P. Also, there's 5 chlorine atoms on the left side, so 5Cl. And 5 chlorine atoms on this side, 5Cl. Continue with the rest of the atoms. This is your balanced equation.
Babe, do you want to go get your pen today?
Excuse me, miss, can I borrow your man real quick? Oh. Sir,
Yes,
do you know
miss.
how to find the limiting reagent in a reaction?
I don't speak English.
The limiting reagent is a reactant in a chemical reaction that determines the amount of products produced, so it basically limits the reaction. The reaction will cease to occur when the limiting reactant is used up.
In order to find the limiting reaction of the problem, we have to first know the balanced equation. So we see here that 3 moles of sodium hydroxide reacts with 1 mole of phosphoric acid to produce sodium phosphate and 3 moles of water. So the problem asks us if 35.6 grams of NaOH reacts with 30.8 grams of H3PO4, how many grams of Na3PO4 are formed and what is the limiting reagent? So in order to know this, we have to find the molar mass of each of the things that we're interested in. So the molar mass of sodium hydroxide is 40 grams, the molar mass of the H3PO4 is 98 grams, and the molar mass of sodium is 163.94 grams. In order to find out which one is limiting, we have to do we have to find the grams of Na3PO4 found, but in regards to both of the reactants. So we start off with 35.6 grams of NaOH, and then we start off with the molar mass. So 1 mole of NaOH over 40 grams of NaOH times the 1 mole of Na3PO4 with the 3 moles of Na3PO4, which we get straight from the balanced equation, and then we multiply that with the 163.94 grams of Na3PO4, which we're trying to find, over the 1 mole of Na3PO4, which we got from the balanced equation, and we find that we get 48.64 grams of Na3PO4 from the NaOH. And the next one, we have to find the product of Na3PO4 from the H3PO4. So we start off with 30.8 grams, and then we multiply by the 1 mole of H3PO4 per 98 grams, so that is from our molar mass, times the 1 mole of Na3PO4 from per 1 mole of H3PO4 from the balanced equation, and then times the 163.94 grams of Na3PO4 per 1 mole of Na3PO4 from the balanced equation once again. And then we find that it's 51.52 grams of Na3PO4 produced. So, since the sodium hydroxide formed less product than the phosphoric acid, as we see here, so it's 48, we made 48 here and 51 here. So, the NaOH, sodium hydroxide, is a limiting reactant.
The theoretical yield is the maximum amount of product that can be made. In other words, it is the amount of products possible as calculated through the Stoich problem. This is different from the actual yield, which is the amount one actually produces and measures. So in this first experiment, we measured different amounts of sodium bicarbonate. We used 0.05 mole, 0.1 mole, and 0.15 mole using the handy-dandy molar mass to convert to grams. We used 10 milliliters of 3 molar hydrochloric acid for each flask, which is 0.03 mole. We then blew up the balloons and released the air to stretch them, making it easier for the gas produced to blow up the balloons. We then poured the sodium bicarbonate into the balloon via a funnel, what Lisa is doing here. Then we just wrapped each of the balloons around the flask, and it is now ready for the experiment.
You are just a random pedestrian. I need to ask you a question. Come back! No. Excuse me, miss. What do you know about stoichiometry?
Stoichiometry is the essence of life.
It's the reaction. If the reaction. Miss, before you go.
I'm sorry.
Hard at work.
To check to see if your equation is right.
Whoa, I didn't film yet! Just go. My God, I've been filming the whole time.
Reacting with
1 mole of phosphoric acid. So now,
This will give you the empirical. What will it give me?
Yes.
do you know how to balance an equation?
What kind of equation?
A chemical equation.
I do. I'm a chemistry teacher.
Good luck in AP Chem, and if I survive, so can you.
I have 3 pieces of advice for you, AP Chemistry student. Number 1, do not mess with Mr. Miller. I will find you. Number 2, do your work and study. Do not procrastinate. And number 3, have fun. You know, this is your junior year or sophomore year or senior year of high school, and it's your time to shine. So go ahead and do what you do best, and that is being a great student.
Well, I hope you retained all the information. Rock the AP exam. This class is amazing. Have fun, enjoy it.
To all those watching this video, I wish you luck in the class. I had a wonderful time, and I have to say T. Mill is one of my top 2 favorite AP Chem teachers. He's a cool guy.